Hello there and welcome to Lower 6 Maths L. This is the Applied Practice Paper G. Here we're working on question 7, a forces question. So a cyclist of mass 80 kilograms is travelling with a speed of 18 meters per second. The cyclist stops pedalling and comes to rest without braking due to a resistance force totaling 120 newtons. Find how long it takes the cyclist to stop. So I think what we need to do here, we don't know the rate of deceleration, so I think we need to use an F equals ma equation to find out its deceleration rate, plug it into a Suvat equation to get the time it takes to stop. So any situation where we have a diagram, I'm all over a rubbish diagram, and he's cycling, so his pedals are down there. So on our diagram we have a force that is in the opposite direction to motion, which is 120 newtons, and he's stopped cycling, so there's no force going forward. So in this case here, the force is negative 120 equals mass of 80 times by A, and acceleration here is therefore going to be minus 1.5 or minus 3 over 2. So to find how long it takes him to stop cycling, let's find which parts of our Suvat we know. So we know that the speed initially is 18. We know that they want to come to a stop, so that's v equals 0. A is equal to minus 3 over 2, and t is what we're looking for. So from these four letters here, I'm going to use v equals u plus at. So 0 equals 18 minus 3 over 2t, minus because it's a deceleration, a is a negative value. So t here, rearrange the formula, and you're going to get t is 12 seconds. How do we know it's in seconds? Because that's the units on the speed, and this is generally done with meters per second. Part B is find the distance the cyclist takes before stopping. So now in the Suvat formula we're going to find S. So using the two that we've found before, v squared equals u squared plus 2as, and we're going to get 0 squared equals 18 squared minus 2 times 1.5, that's 3, so S. So S here is going to equal 108 meters. Okay. Part C is describe one limitation of this model. I would say that this resistance force here of 120 newtons is likely to vary depending upon the gradient of the slope that he's currently on or she's currently on, the quality of the surface. So I would say the answer for part C is that the 120 newton force is unlikely to remain constant. Sometimes on a bike the end point of it seems to go on forever and you start to decelerate quite quickly when you're travelling quite fast, so that could be a factor as well. So the 120 newton force is unlikely to remain constant throughout, and hence the deceleration rate will change as the speed changes, or as the surface varies, or as the gradient of the hill varies. Okay, 7 marks for that.